Prudent Scholars in association with Goa Headmasters Association.
I hope you have already watched the previous class and learned those two proofs that we studied. And just to take you back for the last proof, I'll just take a recap of this. This is what we finished on, right? So we tried to prove that if the areas of the triangle are in the ratio, then the corresponding sides will be square of them. So this is what we studied. If you have not watched that video, you can go ahead and watch that. And then let us continue in today's class Pythagoras theorem. And I'm sure you must have studied Pythagoras theorem in class 7. That's where you start studying about it. If you have forgotten, don't worry, we'll brush through it. Okay, so in a right triangle, the square of the hypotenuse is equal to the square of the other two sides. Short and sweet statement. So what is it trying to tell us? If I have a triangle, okay, this time let us give it a name JOF, and there is an angle O which is right angle. Now, they're saying in a right angle triangle, so first condition satisfied. What is happening? The square of the hypotenuse, right? So, what do we mean by hypotenuse? If you don't know, you need to locate the right angle first. Okay, so wherever the right angle is, and exactly opposite in front of it, right, whatever is the side that is there will be a hypotenuse. It is the longest side of a triangle. So two things to keep in mind, right? Locate the right angle, and exactly in front of it is your hypotenuse. Okay, so the square of the hypotenuse is equal to the square of the sides. So let me give some values to these sides of the triangle, and this is what it is telling you. So JF square, which is the hypotenuse, is equal to the other two sides. So another thing that students mostly make mistakes in writing the Pythagoras theorem, okay, and they end up writing any side anyway. So a tip for you to remember is that first locate the right angle, then immediately write the hypotenuse. Okay, square of that is equal to wherever the right angle is, right, the arms of that right angle, okay, are the squares of the sides that you have to add. So in this case, okay, it is the side OF which is squared plus JO that is squared. So all I will do is write those values and check whatever they are telling is correct. So 5 square will become 25, 3 square will become 9, 4 square will become 16, and 9 plus 16 will be 25 equals to 25, right? Simple. But will you really believe me whatever I'm telling? I might have chosen those numbers so strategically that it looks to be that way. But why do you have to believe me? Please don't believe me like that. You need to prove and practically check for yourself whatever I'm telling and whatever is told, is it true or no. So let us prove this entire proof. Okay, so given in triangle ABC, angle B is equal to 90 degrees, BD is perpendicular to AC, prove that AC square is equal to AB square plus BC square. Now, can you imagine which one will be the hypotenuse over there? Without the figure, it is the side AC, right? Because the hypotenuse, square of the hypotenuse is equal to the sum of the square of the other two sides. So here I have the triangle, and angle B is 90 degrees. So I have marked 90 degrees over here, and D is, okay, so BD is perpendicular to AC. Now, if that is true, then we are supposed to prove that, right? So what are we going to do? First, we are going to take one small triangle, okay, and that is ADB. and we will write, okay, so triangle ADB, and we are going to consider this big triangle. So two triangles we are considering. We have taken the smaller triangle ADB and then the entire bigger triangle, okay, and it will be, so in these two triangles ADB and ABC, again if you very carefully observe how am I naming them. I started with A, okay, then I went to the angle which was perpendicular, that is D, and then to the other angle, that is B, for the smaller triangle. But when it came to the entire bigger triangle, I again started from the point A, okay, that's the common point which is there. Then I went to the right angle which is B, and then C. So please keep these things in mind whenever you're considering those triangles. In this chapter specifically, the selection of the sides, the vertex of the triangle is very important. So two triangles we have considered, ADB and ABC. Okay. Now in these two triangles, angle A becomes a common point, right? So I can write that angle A is equal to angle A, and it will be called as a common angle or same angle. Okay. Next step is these angles, right, which are right angles. So both of them are right angles, that means they are equal. So it will become angle ADB is equal to angle ABC. Now you will start wondering, like, but that D angle, right angle, is on the other side. So you should know that whenever you have a line, then, and if you draw a perpendicular, 90 and 90, right? So both the sides will be 90 degrees. So angle ADB is equal to angle ABC. Okay, this will be, each is a right angle. Now when two angles of our triangle of one triangle are equal to two angles of the other triangle, we can say that both these triangles are similar, and the reason that we would give is AA similarity test. Okay, so I can write triangle ADB is similar to triangle ABC by AA similarity test. Alright, now once we have written this, we can write the ratios of their sides. So if you can try right now as you watch this video, it would be amazing. So it would be something like this. Okay, AD upon AB. Okay, I'll show it to you. So AD upon AB is equal to AB upon AC, right? And it will be called as CPST. Simple. And next step will be cross multiplying the fourth step. So AD multiplied by AC is done, is equal to AB multiplied by AB will be AB square, and the reason that I will give is step number 4. So from that step number 4 is this is the conclusion. Okay. Next is I will consider this triangle which you can see in purple. I have not colored it internally now, but you get the idea, right? So let us take the triangle CDB, okay, and the entire triangle CBA. Okay, again check how I have named them. If you still have a problem with it, just rewind this video 2 seconds before and then check again. Okay, so here I have used, similarly in the 6th step, I'm saying that CDB is similar to triangle CBA. Now because I have written the word similarly, it only is trying to tell you that Tech Bashin, okay, whatever I have done from step 1 to 5, Tech Bashin yahi proves hota. Okay, it's in that one word similarly just tries to tell you that, okay, Tech Bashin is what you have to remember when you say similarly. But in case you don't write the word similar or similarly, then you can't just write that, because if you write only the with respect to those triangles, then where it is given, it is not given anywhere, right? So you can't straight away write triangle CDB is similar to triangle CBA. You have to write the word similarly, meaning it only tells us that from step number 1 to step number 5, the way you have done it, that same way the other triangles will be similar. So if these triangles are similar, what will be the ratio of their corresponding sides? That would be something like this. So CD upon CB and CB upon CA. So this is what I get, okay, and CPST, corresponding parts of similar triangles. So I hope this is clear till here. Now, 8th step would be, can you guess what we have to do? Whatever we have done in the 5th step, just cross multiply. So after cross multiplying, you will get something like this: CD multiplied by CA. So whatever is there in the denominator, throw it on the other side of equal to, right? So transpose it, the division will become multiplication. That's how CD multiplied by CA and CB multiplied by CB will become CB square. Okay. How did we get this? From step number 7. In step number 9, what we are going to do is, we are going to add whatever we got in step number 5 and step number 8. So add the left hand sides together, add the right hand sides together, and once I do that, it will be something like this: AD multiplied by AC. And by the way, for all those who don't know, that dot, okay, symbolizes multiplication. We don't write X symbol, multiplication symbol over there, is because then afterwards it will look ADX AC, right? So that becomes a little confusing there. So we put, whenever we are talking in terms of geometry, we put a dot which symbolizes multiplication. Okay, so AD multiplied by AC in one bracket plus CD multiplied by CA of step number 8 in the other bracket is equal to whatever is there on the right hand side. Now if you look carefully in this left hand side, I can see that there is AC and there is CA, which is same as AC only, which is two common sides which are there. So all I will do is, whatever is common, I will take it outside the bracket. So it would become something like this: AC will move out from the first bracket, and what will remain inside is AD plus CD of the second bracket is equal to, right hand side is kept as it is. Okay. Now if you look at the figure, notice the figure now. So I have AD and CD, right? So AD and CD is nothing but the entire stretch of side AC, right? So instead of writing AD plus CD, all I can do is write AC over here, and it would become AC multiplied by AC is equal to whatever is there on the right hand side, and AC multiplied by AC is nothing but AC square is equal to AB square plus BC square, and that is what we are asked to prove. So in case you want to copy this down later, you can take a picture or take a screenshot of this and then copy it down later, but please do not by heart. So every proof after it's done, I keep on telling you, do not by heart it, because it's simple, right? It is, trust me. Only thing, you need to understand what exactly we are supposed to do. Just by hearting it will not solve anything. You will just end up rote learning it, and then one side is changed or the figure is turned into something else, then it will become very difficult for you to write the entire proof. So what have we done in this entire proof? We have taken one small triangle and the entire big triangle, right? And then we have tried to prove them similar, keeping in mind how we name those triangles. So we start from a common point, then we go to the right angle, and then we go to the vertex which is just left after that. Okay, so common point, right angle, and then whatever is left. Okay, so we did that, and then we were able to write the sides which are corresponding to that. So we have written those corresponding sides, and then we cross multiply. So just keeping this in mind, you know you have already done step 1 to 5. Then 6th step was Tech Bashin, and then the 7th step where again we write the ratios and we cross multiply in the 8th step. Next, after that is just adding of those cross multiplied steps together, taking that common side out, and then you will end up that common side will automatically become the entire length of that side. Okay, stretch, that is AC in this case, cross multiply it together and you are done with Pythagoras theorem. I hope you have straight away understood it right now. Okay, next thing that we are going to study is converse of Pythagoras theorem. So what is the meaning of converse? It is just that it is telling you if that statement that AC square is equal to AB square plus BC square, which was there as a part of the previous proof, is true, then the angle will always be 90 degrees, right? So, okay, so I have a triangle over here. Okay, another thing to keep in mind, most of the students forget about this, and I have a case where one student came up after the exam got over, and then was I had to deduct some marks because something was incorrect, and started saying that I took a protractor and I measured this angle. It is 90 degrees. Then how can you just cut my marks? So unless and until it is given that it is 90, that means the symbol is put and it is written 90 degrees, please do not believe that it is 90 degrees. Okay, so especially in geometry, you cannot consider it unless and until it is told to you in somewhere or the other. So just because now in this figure, it looks that it is 90 degrees, don't believe. So I have triangle ABC and some values of those sides. And so if in a triangle the square of the hypotenuse is equal to the square of the other two sides, then one angle is 90 degrees. So I have told you already that hypotenuse is usually the longest side, right? So we are squaring 13. Okay, this is usually considering that it is 90 degrees. Okay, we assume that it is 90 degrees and we write this statement. Okay, once we have written it, then we'll substitute the values and check. So 13 square will become 169, okay, 5 square will become 25, and 12 square will become 144. Add the right hand sides and 169 is equal to 169. So because this is true, I can say that angle B is 90 degrees, not before that. Okay, so I hope the statement is clear, and let us go ahead and prove it. Okay, given in triangle ABC, AC square is equal to AB square plus BC square, and triangle LMN is constructed such that LM is equal to AB and MN is equal to BC. Angle M is 90 degrees. Now, prove that angle ABC is right angled at B. So much information, unless and until again no figure, you can't understand. So one again pro tip to remember is that whenever you're solving questions in mathematics or when you're solving the paper, if any statement is given, figure is not there, try and read and spend some time drawing the figure, because the more you see that entire figure, things become more and more clear in your mind. Otherwise it will become difficult. So let's draw the figure. So I have a triangle ABC, okay, and in this triangle ABC, AC square is equal to AB square plus BC square is given to us. Now we have to construct triangle LMN, but what we have to keep in mind is that LM is equal to AB and MN is equal to BC. So it will be something like this. Okay. Based on that, I have drawn the figure. So taking those measurements, I have drawn the figure. And angle M, we have when we are constructing, we kept in mind that it is 90 degrees. Okay. So angle in triangle LMN, angle M is 90 degrees. It is already given in the statement. Next, I can write, if there is a right angle triangle, I know how to locate a hypotenuse, and once I do that, I can write Pythagoras theorem, because there is a 90 degree angle. So once a 90 degree angle is there, I can write Pythagoras theorem. So it would become ln square is equal to Lm square plus Mn square. Okay. Now, what did we use over here? We used the Pythagoras theorem. Okay. Next, we are also given that based on that information that BC was equal to Mn and AB was equal to Lm. Based on that, we drew these triangles, right? So, this was already given. So, all I will do is I will write it. Lm is equal to AB, Mn is equal to BC. Okay, given. Now, we are also told that Ln is equal to AB is AB square plus BC square, right? So, how did we come to this step? What we have done in step number 3 is that looking at step number 1. So, we are writing the entire step number 1 back again, but wherever there is Lm, I am replacing it with AB because Lm is equal to AB. So, and there was a square over here, so this square comes in. Okay. Same way, Mn is replaced with BC, and because there was a square, I will write square over here. So, we have used step number 1 and step number 2 to come to step number 3. Okay. So, I have written that. Now, from here, if you write from in the fourth step, I can say that it was given to us, right? AC square is equal to AB square plus BC square. Now, look at the third step and the fourth step. The right hand side are same. So, left hand side also should be same. So, I can write, I will just write the reason over here, that it is given, and in the fifth step I can say that AC square is equal to Ln square. From how did we get this? From step number 3, which is here, and this, because right hand sides are equal. Okay. So, here is step number 3 and step number 4. Now, if any square of one side is equal to the square of the other sides, then the side itself should be equal. So, because if you take the root on both the sides, it is of the same number, right? So, say for example, AC was 25, then Ln square also will be 25. So, taking a root will be 5 equal to 5, right? So, in step number 6, I can say AC is equal to Ln. Now, what we are going to do is, we will consider triangles LMN, okay, this triangle, and ABC. Now, in those two triangles, we will write that Lm is equal to AB, which was already given to us, Mn is equal to BC, which was also given to us, and AC is equal to Ln, which we have just now proved. Okay. So, taking all these sides, I can write, okay, from step 2 and 5, right. So, step 2, those two sides were equal. In step 6, step 5, we have proved that the other side, AC is equal to Ln. So, from here, I can write that all these sides are equal. Now, if all three sides of one triangle are equal, okay, sides are equal, then I can write by side test, these two triangles are congruent. Simple, right? So, LMN, triangle LMN is congruent to triangle ABC only because all the sides are equal. We are not talking about ratios over here right now, we are just talking about the sides being equal. So, when sides are equal, it is SSS congruency test. Now, if it is congruent, this is like your 9th standard portion, proving two triangles to be congruent. So, here what will happen? If triangles are congruent, every angle of that triangle will be equal to every angle of the other triangle. So, based on that, I can say angle M is equal to angle B, correct? And angle M was how much? 90 degrees, right? So, because CPCT is what we can say, based on that only we can say that angles are congruent, right? So, CPCT, corresponding parts of congruent triangles, right? So, angle M was 90, therefore, angle B will also become 90, and that is how we prove this converse of Pythagoras theorem, right? So, simple, all you have to do is construct that one triangle based on all the information that is given to you. And actually for the exam, you should get both the triangles. So you don't have to construct any triangle. But in case if it is not given, you just have to say AB is equal to LM or whatever the sides are there for the exam, okay? Based on those two sides, you can write Pythagoras theorem, equate them, and there you go. Just chunk all those steps and learn them. Otherwise, I have students who would usually say like, wo kittu le step ko I can't study all this. I'll just leave that chapter and don't bother about it only. But I don't want you to do that. Okay, so chunk those proofs steps bit, and then you'll be able to study. So don't study all. You're studying number of steps, but study in a way that this is a certain step. Like for example, if you are, suppose you're preparing a cake, right? Then there is always, I will get all the ingredients together, put the dry ingredients together, mix them, put the wet ingredients together, mix them, beat them together, and then bake it. So what have I done? The entire cake procedure is divided in 3 steps. So that's how you bake the proofs right, okay? I hope the entire theorem is very clear. If you want to click a picture or take a screenshot, go ahead, do that, and easy, right? Okay. The next thing what we are going to learn is riders. And in case you have your siblings or your friends or someone who has already answered 10th standard board exams, then they will tell you that this riders are questions, that will like literally blow your mind, your ears, your eyes, everything possible, okay? And this is what usually students state is whenever they are, going to solve riders. They feel like just tearing that paper and just throwing it off because riders become that complicated for them. Why? Is because all those proofs that I have just dealt with in the previous class and this class are by-hearted, okay, firstly. So all those steps were just marked up and then written. So because of that, riders become difficult. You don't know the idea. You don't know, if you don't know the letters, then you can't make words, right? So that's how riders become difficult. Secondly, riders become difficult is because there is no perfect recipe for it, okay? Like how I was telling you in those proofs, chunk them together. This is what we have to do right now. Next step, this is what you have to do, and then you have to go ahead and solve. Riders, there is no perfect method, okay? It is all on based whatever you have studied, and not just 10th standard, but in the lower classes, in 9th standard, 8th standard, those concepts need to be used to, make this. So if someone who has prepared a nice dish will not be called as a chef, right? A chef, the title of a chef comes only when you have prepared a number of dishes and you can innovate those dishes according to your, according to people's liking. So I would say if you want to be a chef when you're solving riders, then you need to practice a lot of them, okay? So to start with, we'll take a very simple one, and that's how you will be able to understand, okay? And it looks nice that the person is studying very, completely into the book, but riders cannot be studied like this. You have to practice, write and study. Okay, you can't read riders. Okay, so I have a quadrilateral ABCD, which is a rhombus. Okay, prove that 4 times AB square is equal to BD square plus AC square. Okay, that is what we are asked to prove. Now, I don't know how many of you all know what is a rhombus. If you know, good. If you don't know, then rhombus and squares, right? Long ago they were twin brothers. Just that rhombus got a little bit drunk, and then he couldn't stand straight. He was like standing like that. So that is how it becomes. So square slightly tilted at an angle will become a rhombus. Okay. So what I'm trying to tell you is opposite, all the sides are equal. So ABCD is a rhombus where ABC, all these sides are equal. Okay. Then what are we doing? We start with a construction. So you can, in riders, you can construct whatever you want to prove it, and If you are constructing something of your own which is not there on the question paper, then you will have to redraw the diagram. Okay, so A to C and B to D, this is constructed, okay, and it is intersecting at point O. Another property of a rhombus is that the diagonals are bisected. They are not equal, like in a square they are equal since it was tilting, right? So diagonals are not equal, but they are bisecting equally, okay, and perpendicular bisectors. So OD will be equal to OB, AO will be equal to OC, and it's perpendicular bisection. Now we know that AO is half of AC. So I've just told you that, right? So AO is equal to OC. So if AO is equal to OC, I can say that AO is just half of this entire length of line AC. This is what it means. Okay. Same way, I can write BO or OB is nothing but half of the entire stretch of BD. Right? Yeah. Next, I want you to look at this triangle. Okay, that is AOB, and O is 90 degrees, right? So I'll use Pythagoras theorem, which we have studied in the previous section, that it would become AB square, which is hypotenuse. So 90 degree was over here, and exactly opposite that is my hypotenuse. So AB square is equal to AO square plus BO square. Simple, right? Now what we are going to do is, okay, Pythagoras theorem. If you notice this, AO was equal to half of AC. So wherever there is AO, all I will do is put half of AC, right? So over here, instead of AO, I'll write half of AC. Same way, instead of BO, I'll write half of BD. Where will I write? Over here. So this is what it will get. Okay. Then what I'm going to do is, there's a square outside the bracket, right? So let's square. 1 square will become 1, 2 square will become 4, and AC multiplied by AC square will become AC square. So this is what I will get. So 1 upon 4 AC square. Same way, this will become 1 upon 4 BD square. Okay. Now if you notice, the half over here, 1 upon 1/4 and 1/4 is common. So all I will do is take 1/4 outside the bracket, and I will have AC square plus BD square. 1/4 is taken out. Okay. Now this 4 is divided on the right hand side. So I don't want to keep it over here divided. So all I will do is transpose it on the other side. So division, when it goes on the other side of equal to, will become multiplication, and you will get 4 times AB square is equal to AC square plus BD square, and that is what was asked to prove. That's it. I hope the first and the simplest rider is very clear, and if you want to take a screenshot of this, you can, or if you want the entire file of this presentation, then you can just get in touch with me. My YouTube channel is there. There is a QR code, scan it, or you can write Instagram message to me or an email ID. Okay. In triangle ABC, okay, AB is equal to AC, AE is perpendicular to BC, and D is any point on BC. Prove that AB minus AD square is equal to CD multiplied by BD. Again, too weird to understand without a figure, right? So let's draw a figure. Triangle ABC, right? And AB is equal to AC. So I have the sides done, and since they are equal, let me mark them equal. Okay, and AE is perpendicular to BC. Okay, so perpendicular. D is some point on BC, right? So let me mark a point and join this. Okay, now what are you asked to prove? You are asked that AB square minus AD square is equal to CD multiplied by BD. Now, whenever you're solving these riders, right, most of the times students also come with a question like, So tu kitkonuch kota or proof eshkon gorba daimon. Okay, and that kitkonuch is only because I have practically tried a number of proofs when I'm solving them. And secondly, there's a simple technique. All you have to do is read that entire question, right, and try and figure out what are you asked to prove. Okay, once you have seen that AB square minus AD square is equal to CD multiplied by BD, I will try and relate this proof, right, whatever is asked, to all the four proofs that I have studied. So in the previous videos, we have learned those 4 proofs, right? So they had something as an end result. You have to think this, what we are asked to prove, for which theorem is it trying to relate to. Okay, now if you look over here, I'm sure you will be able to tell by now that there is a side, there is a square, and then 2 squares of side. It somewhere relates to Pythagoras theorem. That is what you can understand, right? So you have already covered 50% of understanding to this proof. That means you have got the picture that I will have to use Pythagoras theorem to get this rider done. Okay, that is how we go ahead and solve. So if there was something proof that was related to a numerator upon denominator fraction type, that means we are talking in terms of the ratios. So automatically I'll have those proofs in my mind. So based on that, I will try use those understandings to prove those riders. That's how that teshkon is done. Okay, so we are supposed to prove that AB square minus AD square is equal to CD multiplied by BD. So we have considered these 2 triangles, right? The one in yellow, the other one in purple. So we will write, consider these 2 triangles. So whatever AEB and AEC. Now, in this triangle, AEB is equal to 90 degrees, which is, we have understood from the question itself that it is telling us that AE is perpendicular. Perpendicular means 90 degrees. So I can write that. Next, if you look at the figure, those 2 equal sides, okay, markings are blinking over there, which is trying to tell you that AB is equal to AC. So that is what we are going to use over here. Okay. Next, what we are going to do is, you can see that yellow color line in between, that is AE, is equal to AE, right? So common side. Correct. So now, what are the 3 pieces of information that we have? We have 2 sides and 1 angle, and there is angle is right angle, plus we are talking in terms of hypotenuse side. So I can say that these 2 triangles are congruent by RHS test, because there is a right angle, there is hypotenuse involved in it, right? So I can say triangle AEB is congruent to triangle AEC, and it is because of right hypotenuse side, or you can say right hypotenuse side congruency test. Okay, once you have proved that these triangles are congruent, all we have to do is, we'll write, now look at the figure carefully now. I can write this BE, okay, is equal to AC. Why? Is because CPCD, okay, corresponding parts of congruent triangles. Based on that, we have proved that. Okay. Next, what we are going to do is, look at this triangle, that is ABE, okay, and I can write Pythagoras theorem for it, because one angle is 90 degrees, right? So I can write AB square, which is the hypotenuse, is equal to sum of the square of the other sides, which is AE square, which is here, plus BE square. Okay, which triangle? Triangle ABE. That's it. Okay. Now, once I have done that, all I will do is consider this triangle, which you can see, that is in red, that is ADE, and I can write Pythagoras theorem for that triangle as well. So when I do that, AD becomes the hypotenuse and is equal to AE square plus DE square, okay, sum of the other 2 sides. So once I do this part, if we look at step number 6 and step number 7 carefully, I have AE square over here and I have AE square over here as well. So what I will do now is I will write the step number 6 and step number 7 in terms of, keeping that on one side and rest all the terms on the other side. So can you guess what would happen to step number 6 if I would keep AE square on one side? It would be AB square, that plus BE, which is on the right hand side, comes on the other side, will become minus BE square, right? So, and it would be written as something like this. Okay, if I would directly write this part over here as a 6th step, you would wonder, this is not Pythagoras theorem, right? So instead of writing too many steps, I have written it and then told you how did I get to this understanding. Okay, so same way, try for the 7th step. I'll keep A on one side and take DE square on the other side. So this would become something like this. Alright, now looking at the step number 6 and step number 7, we can come to an understanding that the right hand sides are equal and therefore my left hand side will also be equal. So in the 8th step, let us equate these. Okay, so I have written AB square minus BE square is equal to AD square minus DE square of the 7th step. So which two steps I have used to prove this? I have used step number 6 and step number 7. Once we have got this, look at the step number 8 and we shall understand looking at the step the figure, right? So AB square is nothing but the hypotenuse, BE square is nothing but one of the side of the right angle triangle, AD square is again a hypotenuse of this triangle which is in red color, and DE is another side. So why not get both of them together? That means all I'm trying to do is get the hypotenuse terms together, okay, the sides together and the other sides on one side. So this would become something like this. Okay, so AB square, AD square, which is on the right hand side, which is positive, goes on the other side, becomes negative. Okay, BE square, which was negative, goes on the other side, okay, transposed and becomes positive, and minus DE square is as it is. Okay, I hope you have understood till here. The rest of the proof we will continue in the next class. Till then, you can take a screenshot if you want to and try and practice this. Thank you.